Our proposal is all about the adaptation and the use of solar-powered water pumps in Barangay Canaway, Siaton Farmlands. Philippines is one of the most agricultural countries in the world. It houses different types of bodies of water with lands and climate that is best for different types of vegetations. However, Philippines' agricultural sector is declining due to its lack of infrastructures on farming and irrigation. Climate change has the potential to disrupt crop productivity. Higher temperatures interfere with the ability of plants to get moisture, thus affect the agricultural production. The best alternative to combat this rising issue is to exhibit the adaptation on the use of solar-powered water pumps. These pumps use the energy coming from the sun to run in order to provide water for the field. Climate change has the potential to disrupt crop productivity. Higher temperatures interfere with the ability of the plants to get moisture, thus affect the agricultural production. In response to this issue, irrigation is of great importance. Having enough water to supply to the farmlands will help it yield better harvest. The best alternative to combat this rising issue is to exhibit the adaptation and the use of solar-powered water pumps. This pump uses the energy coming from the sun to run in order to supply water to the field. An irrigation system that uses solar-powered water pumps is a great help to farmers, and it will give them hope that something better is coming on their way. Farmers of Barangay Canaway also experiences this issue relating to irrigation systems. The existing canal systems that they have imposes a lot of disadvantages, including its drying during hot seasons. According to Billini 2020, crops harvest rises with the use of solar-powered irrigation project. This system has helped farmers in the Philippines become less dependent on rainfall. The proposed adaptation and the use of solar-powered water pumps will serve as the solution to combat this rising issue in this context.
Statement of the problem. This research study is solely based on the issue that the researcher wants to address. As stated, climate change has caused a tremendous impact to the lives and production of farmers. Every sector in the government is continually dealing on ways to address the concern. The constant rise of temperature due to global warming brings detrimental effect to the growth of crops. As a result, there is deficiency in food production. Farmers in Barangay Canaway, located in mountainous area in municipality of Siaton, also experiences this issue. This barangay houses different types of crops and vegetation that is affected due to global warming. The existing canal irrigation in the area imposes different risks and disadvantages, including the imbalances of the distribution of water, which lead to crop damages. On account of this, an adaptation to the use of solar-powered water pumps to power a drip irrigation in the area will be considered. Specifically, this research aims to answer the following questions. First, what will be the total of the solar panels and water pumps to be installed in Barangay Canaway, Siaton to supply the farmlands? Second, how many watts is needed to power up the water pump installed in the area? The last one is, how much is the total amount spent on the installation of the solar panels and water pump? Scope and limitation of the study. This study will focus on the adaptation of solar-powered water pump to supply the irrigation system in Barangay Canaway farmlands. Drip irrigation is used as a basis for this study because it is more efficient and has more benefits to the plants and to the system as a whole. For the purpose of this study, cornfields will be used. However, once the system is implemented, the operation will depend on the farmers on whatever type of irrigation and vegetation they want. The farmers of this barangay will be the respondents of the study where certain data will be gathered. Moreover, it will provide the basic calculations to identify the number of solar panels required for a certain area of need as well as the water pumps. As this will focus only on the solar-powered water pump system, the implementation of the drip irrigation system will not be included. Implementation referred Here is how the drip irrigation is created. This part may be focused for further researches.
The theory that is utilized in this study is based on the concept of the solar-generated electricity called photovoltaic and the working principle of the water pump. Photovoltaic system is composed of one or more solar panels combined with an inverter and other electrical and mechanical hardware that use energy from the sun to produce electricity. French physicist Edmond Becquerel noted the photovoltaic effect in which certain materials would produce a small amount of electric current when exposed to light. The smallest element of the PV panels is called the solar cell, also known as the basic photovoltaic cell. These cells combine together from a panel which collects the renewable energy from the sun and converts it into electricity, which will then be used to power electrical load. The load here in the system is the water pump. Water pumps, on the other hand, is a water control equipment that utilize pumping and evaporation to function. These are often used in construction sites as a form of water extraction, as well as in agriculture to move water from the water source to the vegetation. The working principle of the water pump depends upon the positive displacement principle as well as the kinetic energy to push the water. The solar-powered water pumps integrate the combination of the two concepts concerning solar energy and water pumps principles. The electricity produced will be used to power the entire system. The system will work through the utilization of the power coming from the sun through the use of photovoltaic panels. These panels convert light from the sun into electricity to be used to power loads. The amount of electricity generated will be dependent on the solar radiation of the place where the solar-powered water pump will be installed. Intensity of the sunlight striking in the panel is affected by weather conditions and the topography of the area where the proposed system will be installed. The figure shows the relationship of the dependent and independent variable involved in this study. The dependent variable will be the electricity generated, and the independent variable is the sunlight. This figure shows the block diagram of the entire system, in which the whole system is powered by the energy coming from the sun, which will be absorbed through the solar panels. The charge controller present is set to control the voltage and current to prevent batteries from overcharging. It regulates the voltage and current coming from the solar panels going to the battery. Rechargeable 12 volts battery is involved in this system so that electricity can be stored and the pump would still function even though sunlight availability is constrained. Power is supplied by the batteries for operating the system. Water is pumped from the surface solar water pumps from the river to a storage tank, and the water is then drawn to the irrigation drip system to deliver water to the crops and vegetation.
So good day everyone, my name is Jefprill John D, Ebrole, and today I will be discussing to you about our research methodology. So as you can see, this is the diagram of our research methodology. So I will be discussing each step to you one by one. So the design of our solar-powered water pump system that will be needed in this study consists of farmlands like the cornfield, which is one of the main products that is produced by the farmers in Barangay Canaway. It is necessary that we need to know what kind of plant that we'll be using in order to know how much water we will need to supply. So we decided that we will be using corns as our plant. So as you can see, this is a photo of the river that is found in Barangay Canaway. So it has a great abundance of water that is good as to be used as a source of water in our water pump system. It is necessary to determine the size of the system needed, including the pump, PV panel, the battery that will be used in storing electricity from the panels, appropriate mounting structures, pipes, tank size, and drip irrigation distribution lines. However, this study is limited to not include the sub-information for the drip irrigation system. So yes, as I said earlier, that this will be conducted in the Barangay Canaway. There is a need to identify first the water that will be needed to supply the total needs per day in the area. To determine the total water requirement in the area, there is a need to calculate the total water needed and the type of plant that will be supplied with the system. So the researchers have decided to use corn plant because Barangay Canaway is one of the main producers of this product. The total area that will be supplied by the solar-powered water system will also be considered. For instance, 1 hectare of cornfield. To calculate the water requirement, get the number of corn plants and the corresponding approximate water needed per corn to grow. According to the data from the Food and Agriculture Organization, corn plants need approximately 6.1 millimeters of water per day. Millimeter of water referred is the pressure exerted at the base of the fluid, exactly 1 millimeter. For 1 hectare of land, there are approximately 10,000 corn plants. Assuming 1 meter distance per plant, calculation of the water requirement goes water requirement needed is equal to the number of plants times the water required per plant. Then we need to substitute the values, example 10,000 plants, so the water needed per plant is 6.1 millimeters. So we need to multiply that, then it will be 61,000 millimeters per day. So noting that 1 millimeter of water is equal to 0.01 cubic meters, so and it is also equal to 1 liter, so the water requirements needed is equal to 61,000 liters per day. So next, the researcher needs to determine the layout of the entire solar-powered water pump system, which includes the location and elevation of the water source, the pump that will be used, PV panels, storage, tanks, and the areas where the pipelines will be placed. So the location of the PV panels will also be a great factor in the whole water pump system. So there is a need to consider that the area will be put into less obstruction of shadows to have more efficient system. So there is also a need to put into consideration the safety of our equipments in the system. So to have additional safety, it is essential to put fencing around the system. Identifying the type of water pump that will be used is a need so that the flow rate of the pump can be computed. In order to compute for the flow rate, first compute the total number of waters needed per day divided by the total daily solar insolation in minute. Suggested that the solar insolation will be 6 hours, that is from 9 a.m. to 3 p.m. per day, as this is the time where the solar energy is mostly supplied considering the location. So next, another importance of identifying the type of water pump to be used is that it will help identify the total amount of voltage needed to run the water pump and to know how many PV panels needed to supply enough for the power pump. To compute the total voltage needed, multiply the voltage needed per pump with the total number of water pumps that will be used. So next, the actual installation of the system will also be a great factor for the efficiency of the system. There is a need to consider that the elevation of the PV panels to know how many degrees will be tilted to make it more efficient for the system. So tilting the PV panels for about 30 degrees is recommended for better efficiency. The time of the day and the month will also affect the efficiency of the system, because different time also means different sun peak hours. So now, we will be talking about the pipelines that we will be using in this study. So there are many types of pipes that are available for the irrigation system, but for this study, we will be using 3 different types of pipelines, which are PVC Scheduled 40, the pressure-rated PVC, and the black-rolled pipe will be used. So these 3 kinds of pipes are the best pipes that can be used for this study. Not only this is affordable compared to other kinds of pipes, but also it is easier to work within different kinds of landscape. So now, finally, after gathering all the data that is needed that was mentioned earlier, installation of the system can be exercised. Still, total cost of the installation of the system will be needed to identify. To determine the total cost, add all the expenses of the materials that will be used, which includes the number of PV panels, the number of water pumps needed, and the length of the three kinds of the pipes that will be used in our system. So the cost will also include the labor of the installation. So researchers need to identify the number of people that will be working, which includes the number of electricians to be in charge in the electrical installation, the number of plumbers, which is in charge of the pipeline installation, and the number of construction workers that will be in charge of the construction of the place where the PV panels will be placed. So that's it for our research methodology in our research proposal. So hopefully you understand our study, and God bless you always. Thank you.